Alright, 6.4. Prove triangle similar by AA. AA stands for angle angle. Basically, if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. Okay, so you don't have to prove that all three angles are congruent and all three sides are proportional. If you got two angles that are congruent, you're good. So for example, determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasonings. Alright. Because both right angles, angle B and angle E, because they are both right angles, angle B and angle E are congruent. By the triangle sum theorem, 68 plus 90 plus the measure of angle A has to be 180 degrees. So the measure of angle A is 22 degrees. Therefore, angle A and angle D are congruent. So, these two triangles are similar by the angle-angle similarity postulate. Okay, you guys try these two. Let's go on to page 2. Show that the two triangles are similar. Alright, triangle RTV and triangle RQS. You may find it helpful to redraw the triangles. I'm going to redraw these two. So we've got RTV, this is 49 degrees, and we've got RQS. If we can show that two angles are congruent between these two triangles, we're good. Because the measure of angle T and the measure of angle Q both equal 49 degrees, angle T is congruent to angle Q. By reflexive property, angle R is going to be congruent to itself. Notice that both these triangles share an angle. So if we have two congruent angles, then the triangles have to be similar by the angle-angle similarity postulate. This one's a little bit trickier. Triangle LMN and NOP. We know that this angle is congruent to this angle. The diagram shows that. It also shows that this and this are parallel. Okay? So MN is parallel to OP. So if you think about it, because both of those lines are intersected by this transversal, this angle and this angle have to be congruent because they are corresponding angles. So angle LNM is congruent to angle P by the corresponding angles postulate. So we have two angles. These two triangles are similar by angle-angle similarity. Alright, you guys can do the checkpoint. Let's go on to page 3. A lifeguard is standing beside the lifeguard chair on a beach. The lifeguard is 6 feet 4 inches tall and casts a shadow that is 48 inches long. The chair casts a shadow that is 6 feet long. How tall is the chair? Alright, so this is our situation. The lifeguard and the chair form sides of two right triangles with the ground as shown below in the diagram. The sun's rays hit the lifeguard and the chair at the same angle. So you have two pairs of congruent angles. Once again, the right angle and this angle. So the triangles are similar by angle-angle similarity. We can use a proportion to find the height of x. Write 6 feet 4 inches. 6 feet, there's 12 inches in a foot. 12 times 6, hopefully you guys know, is 72 inches. 72 inches plus 4 inches is 76 inches. So you can form two ratios of feet to inches. X feet over 76 inches equals 6 feet over 48 inches. Okay? When I cross multiply, 48x equals 76 times 6, 456. I'm going to pull out the calculator. If I divide both sides by 48, I get 9.5. So the chair is 9.5 feet tall. And you guys can do the checkpoint. That's all.